Welcome to the Sophistic online documentation. In this video of the Composite Bridge tutorial, we show how to calculate stress ranges for the fatigue design checks. Before we start with the input, some notes about the concept for calculating stress ranges that we present here. The stress ranges in the composite section are calculated from the maximum and minimum forces and moments that occur during the passage of the fatigue load model FLM3 over the bridge. However, this action is not the only relevant one for calculating the stress ranges in the section. For calculating the effects of the loads from the fatigue load model, it is important if the composite section is cracked or uncracked, or framed differently, if the concrete in the section is subjected to tensile forces or if it is in compression. To judge this, the typical load level on the bridge during the passage of the fatigue load model is relevant. According to Eurocode, this load level from so-called non-cyclic actions should typically be assumed to be the frequent combination of permanent loads, settlements, and temperature loads, combined to give the most unfavorable effect on the stress range. In our case, we get this by combining the non-cyclic actions to give the minimum bending moment My, because this gives the highest chance that the concrete is in tension, therefore assumed to be cracked, so giving the least sectional resistance. Okay, now let's start. Before calculating the fatigue loads, we will create the base combination of non-cyclic actions. For this, we first create an action to store and reference the created results later on. So let's go to the action manager and we will add a new action, a user-defined one. I will call this BFAT for base combination fatigue. We do not need a category and I will call it base combination fatigue. This action should then be later on treated as a permanent action, and it should not itself produce stress ranges, so make sure set the safety and combination vectors to 1.0. Now let's create the corresponding combination. You should be already familiar with creating combination rules from session 4 of this tutorial. We open the task combination rules for actions. Now let's create the base combination. The superposition for the non-cyclic actions should be done as frequent combination of permanent loads, temperature, and settlement. Typically for the fatigue, the investigated point in time for this combination is the end of life cycle. So we can duplicate the already defined frequent combination for the serviceability limit state checks. We assign the results of this combination rule to the previously created action for the fatigue base combination. Give it a title and assign a base load case for the results. Then we modify the combination rule so that only temperature and settlement remain as variable actions. Okay. Then let's rerun the combination rules task. And then we do the corresponding superposition using the task superpositions for combination rules. Add the created combination rule. And as noted, we want to get only a superposition for the minimum bending moment My. for beams and design elements. Okay, let's run the task. And let's check out the created superposition load case. Okay, that's our base combination of the non-cyclic actions. Next, we proceed with the cyclic action from the fatigue load model. We first create the cyclic action in the action manager using the predefined action fatigue traffic load. Then we calculate the internal forces and moments due to the fatigue load model FLM3 from Eurocode using the traffic loader. Please reopen the traffic loader task that we have already used previously for the traffic loads from load model LM1. Now we add a new load model, FLM3, create a new load group. Remember to assign the correct action to the result load cases and create two cases for the load position. One for the right alignment and one for the left. Then run the task. We can take a look at the created results. Okay, now we have the results from the fatigue load model available and also the base combination of non-cyclic actions, and can define the combination for the design load cases that we then actually use for the calculation of the stress ranges. Let's go to the combination rules for actions task. Create a new combination. Now we will assign this to the characteristic combination, as we do not use any safety factors here. Give it a name. Give a base load case number. And assign the actions. So the non-cyclic one that we call base combination fatigue, and the cyclic one containing the traffic loads. Here we make sure to have the correct factors applied. Okay, and then create the combination and run the task. And do the superposition. We go to the task superpositions for combination rules. Here we add the superpositions for the new combination rule. There we are primarily interested in beam and design element results. We will also adjust the title to recognize the load cases later on. Okay, let's run the task. Now we can use the created load cases and calculate the stress ranges. Open the Composite Bridge Design Checks task. Select the calculation for stress ranges for the fatigue design checks. Go to the corresponding tab. The load case selection here offers all superposition load cases assigned to the characteristic and frequent combination. Now let's select the load cases from the previously created fatigue combination, superposed for the maximum and minimum bending moment My and maximum and minimum shear force reset. Note that the stress ranges will be stored under the given load case number, while the underlying stresses of the individual load cases will be stored under a load case number created from the original load case number plus the given offset. Note also that the tension stiffening effect is considered by default. We will also add a detailed output here, for example, somewhere in the span. Okay, let's run the task and take a look at the results. For each material in each section along the girder, we get the maximum stress range for axial and shear stress at the decisive position in the section from the investigated load cases. And usually more important, also the stress ranges of the stress points defined in the section. These are also plotted along the sections of the girder and also visualized in corresponding overview plots. So we have here the stress points web T for the stress point at the top of the web and web B at the bottom of the web. So you can see the axial stress ranges and the range of the shear stresses and use them to do fatigue design checks. Note also that when requesting a detailed output at a certain section, you will get the range of the stresses occurring in the section from min to max, plotted in green. Now you have seen all the tools that we currently provide in our new graphical workflow for the design of composite bridge girders. As final step, we can now select all the checks in the task that we have done in the previous sessions and run the task to get the complete report and the results. I hope you will find the presented tools useful and enjoy trying them out.